Okay, so today we will be talking about finding the angle between two planes. Yeah, might seem hard. You're like thinking, how in the world do you do that? Well, it's quite literally just finding the angle between two vectors. Can you guess what two vectors they are? Pause the video, try out literally two vectors given in the equations of planes. I'll actually write it down right now here. Let's write down the equation of a plane, like 2x minus y plus 3z 3z is equal to 1, and like maybe x plus y plus z, right, equal to 0. Guess what two vectors you're solving for? Well, those two vectors are literally just the normal vectors. Since both the normal vectors are perpendicular to the planes, right? So they create a 90-degree angle. They're all, let's say, translated 90 degrees from the directions of the planes, correct? And if they're both translated 90 degrees, then the angles between the normal vectors will be the same angles between the planes. So all you have to do, extract the normal vectors from the angles of the planes. So extract the normal vectors. So you get the normal vectors, and then just solve for the angle between them. And let's put that in like a big green box. Bad green box. A big green box, just to let you know. It's two, well, not two steps necessarily, but it's two big steps. Because the angles between the normal vectors are the same angles between the two planes. Let's go ahead and just solve for that. So, what are the normal vectors here? The normal vector, let's call this A. And let's call this guy plane A, and let's call this plane B. So, the normal vector of plane A is equal to, and not the magnitude. What am I doing? I just did the dot product video. That's probably what I'm making, writing the magnitudes. But okay, what's the normal vector of plane A? Well, it's 2, -1, and 3 because I extracted the coefficients of each component inside of the equation of the plane. So these are the coefficients: 2, -1, and 3. And the normal vector for plane B is 1, 1, 1 because those are the coefficients of plane B. The end number does not matter. Once we have the normal vectors, all we have to do is solve for the dot product between them, because the equation of a dot product gives A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. So once we do that, you have 2 times 1. So 2 times 1. Let's write down A dot B first. So A dot B is equals 2 times 1 plus -1 times 1 plus 3 times 1. This is equal to 2 minus 1 plus 3, which is equal to 4. Okay, 4. Once you have that, well, all you have to do is solve for the magnitudes of vectors A and, so 4. Solve for the magnitudes of vector A and B. Let's do that like somewhere reasonable. I don't know, like here. Yeah, let's just section it off. Okay, so the magnitude of vector A is equal to the square root of all its components squared. And the magnitude of vector B is equal to the square root of all its components squared as well. So they're just 1 plus 1 plus 1. I'm writing square just so you guys don't get confused. I'm not skipping steps. 4 plus 5 plus 9. 14. I'm never messing that one up again because I messed that one up in the cross product angle between vectors video. Okay. Once we have that, let's plug everything in. You have 4 for the dot product between A and B. You have the magnitude of A is square root of 14 times the magnitude of 3 square root of B, cosine of theta. Let's try to isolate theta. So we have 4 divided by 14, square root of 14 times 3 is equal to the cosine of theta. Arc cosine everything, and then you get theta isolated. Square root of 14 times square root of 3 is equal to theta. And let's go ahead and solve for theta using our TI 84 plus. That's not me flexing on you guys, by the way. Like, this is an old ass calculator. Our cosine answer. Okay, 51.89 degrees. So this is the angle between these two planes right here. Let's go ahead. Let's do another problem. Oh, maybe I should start checking my work after this. But let's go ahead. Let's go make another two planes. Let's pick like 6x. I don't know, 6x plus 3y minus 2z is equal to 0. Negative 9x plus y minus z plus z is equal to 5. I don't know. This number doesn't matter when you're finding the angles between the two planes. The numbers at the end, yeah, that's what I meant. Do not matter when you find the angles between the two planes. Let's get the normal vectors. So this is plane A and this is plane B. So the normal vector of plane A is equal to the components, all the corresponding points for that vector. So we're getting negative 9, 1, and 1 here. Negative 9, 1, 1. I did not intentionally put 9, 1, 1, by the way. That's just happened to be there. Okay, let's solve for A dot B. So A dot B is equal to 6 times negative 9 plus 3 times 1 plus negative 2 times 1. This is equal to negative 54 plus 3 minus 2. Yo, what? Oh, this is easy. This is plus 1 is negative 53. So that's their dot products. The angles between two planes shouldn't be obtuse. I guess you could make them obtuse, but I guess both answers could work. Yeah. Let's just keep going. Negative 53. Oh, what's the next step? Oh, well, this is the dot product. So the next step is find the magnitudes of vectors A and B. Let's find the magnitudes of vectors A and B here. So magnitude of vector A is equal to the square root of 6 squared, 3 squared plus 2 squared. The magnitude of vector B is equal to the square root of 9 squared plus 1 squared plus 1 squared. And this is 36 plus 9 plus 4. And then 81 plus 2. I don't know why I need to use a calculator for that. Oh, square root of 49. How can, not 47. 49, how convenient. This is just 7. And then this is the square root of 83. So we have the magnitudes of vector A and B. Let's write down the formula for the dot product again. Equal to the magnitude of vector A times the magnitude of vector B times the cosine of theta. Plug in all the values, we get negative 53 is equal to 7 times negative 83 cosine of theta. Okay, so after that, isolate theta, cosine of theta, and then you get arc cosine of negative 53 over square root of 83 times 7. I don't know why I switched the order there. Doesn't matter. Equals theta. Yeah, kind of running out of space. And then theta just equals to what? Oh, let's put this through a calculator. Negative 53 divided by square root of 83 divided by 7. And then arc cosine that. You get 146.21 degrees. And I'm not going to lie, now that I'm thinking about it, I'm pretty sure you can just subtract, and let's write this down. I'm pretty sure, okay, like imagine you have, let's erase these parts. I just conclude, you can just end this video here. There's like no more solving, but this is just something I just thought of right now. Pretty sure, let's say we have a cross section of a plane like this, right? So this is just looking at the plane from the side angle, right? It's another plane from the side angle, right? So these are the two planes, and we're looking at them from the flat sides, not from the sides that they're literally like, I guess, looking at you at. I don't know. Like we're just looking at it from the side views, not from the top views of the plane. There you go. That's what I'm talking about. And we're trying to solve for the angles between them here, but we can actually just use the angles here too. And theta, let's call this 1 and theta 2. We just solve for theta 1 here because this is the obtuse angle, 146.21 here. But we can actually just subtract it 180 from this. And we can also just get the angle of theta 2. So I think that, I'm not going to lie, I'm going to check this after. But I think that and I'll put it in the description, like if this is right or not. But I think that you can actually just use both of these answers on this. So if you have any questions, put it down in the comment section. Hope you learned something.